Awesome. So now we got the spawn position being tracked correctly on the hands. Next up, we're going to create a custom gesture to detect whether the hands are open or closed. So what we want to do is in this reality view, we're going to have a new state variable, and let's call this is hands open. And this would be a type bool, and let's make it an optional. And this would keep track of whether the user's hands are opened or closed. Great. So let's get the logic for this hooked up so that we can track whether the user's hands are open or closed in real time. So for that, again, what we want on a high level is here when we call the process hand updates bit, we got the is open hands being passed from this closure, which we've hard coded for now, and then the spawn position. So right now we got the spawn position set, but the is open hands, we're going to set that here now. So let's say is hands open. This is the state variable here. So we're going to set that to whatever we receive from the hand tracking provider. So is open hands. So essentially we're setting the state variable, which tracks the gesture in real time, to whatever we're receiving from this hand tracking model. Obviously now if you go inside this process hand updates call, click and jump to definition, you'll see in the hand tracking model, we got the process hand updates function. And here at the moment, we're looping through each of the hand updates and then detecting the spawn position here. And then we're passing that spawn position to the content view by using this closure, right? As the callback. So this closure essentially has a bool which would track whether the hands are open or closed. And for now, we just hard coded it to true, meaning it should always be open. And then we also pass in the spawn position in this closure. Right now, what we're going to do is we're going to replace this hard coded value to an actual value that would show whether the user is opening or closing their hands. So let's do that next. So here, the way we got the spawn position was we created an extension to the anchor, the hand anchor, this guy here, and created a computer property there, which calculates the spawn position based on various joints in the skeleton. So now we're going to create a similar computed property, but this time for detecting whether the hands are open or not. So what I'm going to do is call this var is hand open, and then this would return a boolean. So let's just return true for now, a hard-coded true. Now what we can do is instead of triggering the callback here, I'm going to get rid of that. Now just after we get a spawn position, we're going to get the information about if the user's hands closed or not. So for that, we're going to do is hands open equals hand anchor dot is hands open. And then finally, once we've got both of that, then we can simply pass that to the callback by doing like this and replacing the hard-coded true value to whatever the value we get from the hand anchor is, just like that. Now, obviously this guy here is hands open. It's hard coded here at the moment. So we're going to replace that with some actual logic. Great. So the way we calculated the spawn position, if you remember, is by using the skeleton data and looking at the middle finger joint, the position of that. And we converted that to world coordinates, and we used that as the position to spawn the fireworks from, or in our case at the moment, to place the sphere in. Similarly, for our hands open gesture, this guy here, we're going to use the joint and skeletal data that comes with the hand anchor to determine whether the hands are open or not. Now, how do we do that? Let's look at the diagram again. Now, if we look at all the data we get from ARKit for hand tracking, you can see again, there are all the different joints here. And if you think about it, to detect an open or closed gesture, what we can do is say if we have the tip of the index finger, so number 9 here, and say the tip of the little finger. If you just visualize for a second, the tip of the index finger and the tip of the little finger, when your hands are open, they'll be the furthest apart, right? So the distance would be the largest. But when your hands are closed, the distance between the tip of the index finger and the little finger would be shorter. It would be much closer together when the hands are closed. So in a very crude way, what we can do is we can measure the distance between these two tips, the tip of the index finger and the little finger, and have a threshold where we say if the distance is bigger than this threshold, that means the hands must be open. But if the distance is smaller than that threshold, that means the hand must be closed. So that's a very hacky way, but a very reliable way at the same time of detecting whether the hands are open or closed. Great. So what I need essentially then is number 9, which is the hand index fingertip, that joint. And then what we need is also number 24, which is the hand little fingertip. So the little fingertip and the index fingertip, by getting the joint data for both of those fingers, we can measure the distance between them and then use that to detect whether open or closed. So now we're going to go back to our code. So again, here we have an extension to the hand anchor. The hand anchor contains all the skeletal and joint data, and we use that and we create a new computed property here called spawn position to get the spawn position of our fireworks from the hand skeletal data. Similarly, here we have our is hands open, which should return whether it's a true or not based on the distance between the two fingertips. So that's what we're going to implement here. So here for this custom gesture, what we're going to do is first, we need the hand coordinates. So this is the hand's position relative to the world. And then we'll get the finger coordinates relative to the hand. So this would be the index finger tip and the little fingertip. So both these joints at this point would be relative to the hand. And then what we'll do is we'll use these two information to get the fingertip data in world coordinates. So here we'll convert to world coordinates. And then what we'll do is we'll use that information about where our index fingertip and the little fingertip is, and we'll measure the distance between those. So measure distance between fingertips. So essentially the index finger and the little fingertip will measure the distance between those. And then once we have that distance, we will decide if closed or open hands based on a threshold. So that's all the steps we're going to do here to essentially get this custom gesture working, right? We got the hand coordinates relative to the world. Then we get the finger coordinates, namely the little finger and the index fingertip. And this would be it relative to the hand. And then we'll convert the finger coordinates to world coordinates so that we could use it reliably. And once we have it to world coordinates, we'll measure the distance between the fingertips, and then we'll use that distance and see if it exceeds a threshold. And if it does exceed a threshold, we know it's open hands. If the distance is below the threshold, we know it's closed hands. For these 3 bits, I'm just going to copy paste code because we've done it before, so you already know how it works. So here first, essentially I have hand from world. This is essentially, again, information we get from the hand anchor. Again, self here is the hand anchor, and from that we get the origin from anchor transform, which gives you the hand position and world coordinates. And then for the finger coordinates, we got this guy here. So here, ignore this error for now. I'll explain that soon. But for now, what we have here is the index fingertip relative to the hand and the little fingertip relative to the hand. So again, here we get this information from the hand anchor. We get the skeleton, the joint, and the index fingertip and its anchor. And then similarly, we got the hand skeleton here, the joint, and the little fingertip. So the little fingertip and the index fingertip is what we have here. And these are relative to the hand. Now here, the reason why we have this error is because we are unwrapping this, and if this does not exist, we're returning nil. But obviously for that to work, we need to make sure this is hand open computer property is an optional. Great, so that error is gone. Now if you go back to the processing hand updates function where we make use of this computer property, you need to make sure we unwrap this because we just made this an optional, right? So what we're going to do is here where we get this is hands open from the hand anchor, the extension that we're just building out. What we can do is here simply unwrap it by saying guard let is hands open, else return. Awesome, so that error is gone now. Great, so now we got both the index finger and the little finger tip relative to the hand. Now both these are relative to the hand, so we need to convert that to world coordinates. For that to work, first we have this. Here we have the index finger position in world coordinates, and what we do essentially is we use the hand world and we matrix multiply that with the index finger from hand guy here. So this is in hand coordinates and this is in world coordinates, and by doing matrix multiplication we get the index finger in world position. And then we do the same thing for the thumb position, and again we matrix multiply the hand position from the world and with the little finger from hand, which is relative to the hand, and by multiplying both those we get the thumb position in world coordinates. This is spelled wrong. This should be the little finger position. Great, so now we got both the index finger position and the little finger position in world coordinates. So these are both as a SIMD3 float, and we can now calculate the distance between these two vectors. Now to calculate the distance between these two vectors, we got this distance function, which comes with the foundation framework, I believe. And here we can pass in the index finger position and the little finger position. So this guy essentially measures the distance between these two fingers. So this distance, now we can use it to detect if it's closed or open hands. So here what we can say is, let's say is hands open. If distance is more than say 0.1, a threshold of 0.1, we can say is it's hands open. And if it's false, we can say is hands open is false. So here we're simply defining a threshold of 0.1. If the distance is more than that, we know it's hands open. And if it's less, we know its hands are not open, and we assign this as false. Great. And now we can simply return that value here, right? So return is hands open. Obviously, to make it cleaner, what we can do is we can simply return this guy here. So get rid of this and then simply return the result here like that. Awesome. So that's this computer property done. So this computer property essentially would use the join data that we get from hand anchor to see if what we're getting is an open or closed hand. So this is the custom gesture essentially. So to do that, we first had the index fingertip and the little fingertip relative to the hand, and we converted that to world position here. And then we calculate the distance between both. And then we use the threshold and if it's above the threshold, we know it's hands open. And if it's below the threshold, we know it's hands closed. Great, so that's a simple way of detecting closed or open hands. Great, so now that we have this computed property as an extension to the hand anchor, what we're gonna do is we're gonna pass that up here in the process hand updates function, right? Now again, in this process hands update function, what we do is We loop through each anchor updates and we get the hand anchor. And first we get the spawn position from the hand anchor. And then we get the is hands open, the bit that we just assigned now, from the hand anchor as well. And we have it stored here. And then we can simply pass that to the callback, which is the closure here. And this would notify the main view or any other views using this, whether it's an open or closed hands. So here we get this error because we made this as optional. So we need to make sure we unwrap it. So what we can do is essentially unwrap it here. So say guard let is hands open. This is great. If it doesn't, let's throw a fatal error for now. Again, don't do this in production, just for prototype phase. And say cannot determine if hands open closed. Awesome, so that's all sorted. So now in this process hand updates function, we got both the spawn position and the custom gesture ready. And we pass that to the callback here. And then we trigger the closure here, which will act as the callback. Great, so let's go back to the content view. So now what we get in the content view here again is here where we call this process hand updates function. We get the is hands open and the spawn position. And the spawn position, we assign it to the state variable, this guy here. And similarly, the is hands open, we already assign it to the state variable tracking the hand gesture. Now all this is hooked up correctly, but now we're not using this anywhere, right? We're not using this information about whether the hands are open or closed anywhere. So where do we want to use it? At the moment, we want to use it to essentially show or hide the sphere, right? So to hide or show the sphere, we'll do that all in the update closure of the reality view, where we can update the content in the reality view. So again, here you can see in the update closure, we first retrieve the sphere and then we update the position of the sphere, right? Now, just after updating the position of the sphere, what we're going to do is we're going to add a new step. So here we're going to show hide sphere based on whether the hands are closed or open. So to do that, it's simple. We got the state variable here tracking whether the hands are open or not. So what we can do is simply sphere dot is enabled. This determines whether the entity will be visible or not. So we can make that conditional on whether the hands are open or closed. Is hands open? If hands are open, then we make this true, meaning the sphere would be visible. But if its hands are not open, we make this false, i.e. the sphere is invisible. So now again, it says this guy here is optional, so we need to unwrap that. So let's just quickly unwrap that here as well. So let's do guard let is hands open. And if that exists, great. If not, simply return. Awesome, so now that should work. So again, the update closure, here we retrieve the sphere and we update the position of the sphere, and then we are showing or hiding the sphere based on the hand gesture here, and then we add it to the content. Now let's build and run this and see what we get. So now you can see when my hands are closed, the sphere is not there, but when it's open, the sphere appears. Hands are closed, sphere is not there. When it's open, the sphere appears. Great, so now we know the gesture is working, right? We got hands open or closed. Again, to show you visually, the way we design this custom gesture is we're comparing the distance between the tip here to this guy here, the tip of the index finger. When it's open, the distance is large, so it's above 0.1. That's why we see the hand open gesture and the sphere showing. But when it's closed, you can see the distance is smaller, and we know it's hands closed, and the sphere disappears. Open, closed, open, closed. Awesome, so now we got the custom gesture working and the hand tracking working as well. So we got both the data we need from the hand tracking model. We know where the hand position is to track the sphere over time, and we have a custom gesture to detect whether the hands are open or closed. Awesome, so now we got everything we need, and now it's time to replace the sphere with the fireworks to complete the Loki firework effect. And that's where we have the true magic. So let's get doing that next. Awesome, so now we're finished with the hand tracking bit. We got the hardest bit of this project ready. We have a class essentially, which has a run session functions to start the hand tracking session. And then we got a process hand updates function, which essentially calculates two different data that we need from the hand skeleton in real time. The first data is the spawn position, and then the custom gesture detecting whether the hands are open or not. And both these, we get it from the hand anchor, right? Which contains the skeletal and joint data. And then once we've extracted all the information out, we'll trigger this closure, which will layer the information up to the content view. And now if I go back to the content view, here again, you can see we got the reality view, which displays the 3D scene. When the scene first starts, we add a sphere to it. And the update closure here, what it will do is it will use data from the custom gesture and the spawn position to essentially modify the content in their 3D scene. These two guys, these two pieces of data, the spawn position and the is hands open, the custom gesture, these are the primary data that we'll use to essentially control the firework experience, right? And this again, we got it from the hand tracking model from the process hand updates function. Great, so now we got essentially the sphere in the spawn position and the sphere being shown or not based on the hand gesture. Now what we're gonna do is we're gonna simply replace the sphere with the fireworks. We got all the plumbing in place. We just need to replace the sphere entity with the fireworks. So here for the sphere, we programmatically generate the model entity for it using a mesh and a material. and we created a model entity out of it. Now for the fireworks, we're not going to do it programmatically, obviously. Instead, we'll jump onto Reality Composer Pro, a no-coding 3D scene creation platform that Apple provides, and we'll design our fireworks there, and then we'll load the entity from that scene and use it here. So instead of programmatically doing it here, for the fireworks, we'll design it in Reality Composer Pro, and then we'll bring it back to our scene here. So for that to work, if you notice, when you created this visionOS project, it came with some templates. So here you can see under packages, if you go to Reality Kit content package, this guy here, and expand that. And then here, if you just click on the package, and then you can see the default Reality Composer Pro scene that comes with this package. It's a simple sphere centered at the origin. Now, if you open this in Reality Composer Pro, what you'll get is you will get the Reality Composer Pro editor, right? So here we have the entity hierarchy. So we can see there's a scene named SCENE. Make a note of this because we'll use this to load the scene from Xcode. And then we got an entity hierarchy displaying the content of our 3D scene. So we got a grid material here and a sphere here at the origin. So I'm going to get rid of both of that. And instead, what I'm going to do is I'm going to put in a firework here right at the origin. So for the fireworks entity, instead of designing it from scratch, what we can do is simply use a template that comes with Reality Composer Pro. So what I can do is if I go here, click add, and you can see you can add different things, primitive shapes, environment, and now you can also see we can add particle emitters. So if I click on a particle emitter, again, there are different ways of configuring a particle emitter. The default one that comes with it is simply like a vertical spawn of fireballs like this. And then if you click on particle emitter, on the right hand side, you'll see the inspector tab where we can edit various properties of this emitter. You can edit emitter values. For example, if I increase the speed to 0.05, you can see it changed. And again, in the particles tab, you can change the spawn colors and whatnot. But we're not going to worry about any of these. We're not going to manually design the fireworks. Instead, we'll use a convenient shortcut that Xcode provides. Namely, if you click these grid icon, you can see there's some pre-made particle effects that we can use, right? There's some impact one, magic one, sparks, rain, and thankfully there's one for fireworks. Exactly what we need for the Loki effect. Great, so what I'm gonna do is simply use that for this, and that will populate the emitter tab with the right values needed. You can inspect it and dissect it if you want, but I'm not gonna go over that now. Great, awesome. I'm gonna simply use that template, and just like that, we got the firework ready, right? So if I zoom in to the viewport, you can see there's the fireworks, and that looks perfect. And obviously there's no sound to it at the moment. We'll configure that later to display some spatial audio, but we'll come to that later. But right now we have a particle emitter, which is an entity in itself, and that particle emitter essentially displays the fireworks. So make sure you click save for this to be reflected in Xcode. And now that we've designed the fireworks entity, what we can do is simply load this in the reality view scene and display this instead of the sphere. You have to remember this is a scene named SCENE, and it has a root entity with the particle emitter. So what we can do is simply load the scene as an entity, and if we toggle that scene entity's visibility on and off, the fireworks will be displayed on and off. And then if we set the scene entity's translation to say wherever the spawn position is, the fireworks will be displayed there, right? So what I'm going to do is essentially load the scene from our reality view and then treat that as the fireworks entity, because again, there's only one entity in the scene, namely the fireworks. If it was a more complex scene, we might have needed to selectively retrieve the entity, but we don't need to do that here. Great, so now I'm going to go back to Xcode. If you click on packages again, you can see it reflects our new Reality Composer Pro scene, right? Again, if you don't see this here, make sure you save it in the Reality Composer Pro project for this to take effect. Awesome, so now I'm going to go back to the content view, and now let's just collapse everything. And now here, what I'm going to do is for the sphere, I'm going to get rid of the sphere, because we'll be replacing that with the scene entity. And now we get some compile time errors, right? So now if I just expand the body of the view, and we see we have a reality view with the make closure and the update closure. Now, again, it says cannot find sphere in scope because obviously we just deleted it. So now what we're going to do is instead of the sphere, we're going to create a new function. We're going to say load fireworks. So this function would essentially load the fireworks scene from the Reality Composer Pro project, and it would take as input nothing, and it would return as an entity. And that's the entity that we can replace the sphere with. Great, so let's do that now. So to load the entity, it's pretty simple. You can use the entity class, and you can see load, and this returns an entity by asynchronously loading it from a file URL. The entity name that we want to load is scene. Again, if you go back to the Reality Composer Pro project, the scene is named SCENE. Make sure you copy that exactly. So the name is scene, and that entity is contained within the Reality Kit content bundle. Again, we're looking at this scene entity here. So we're loading the scene entity. You can see the scene entity right here inside this Reality Kit content bundle. So the bundle we want here is the Reality Kit content bundle, this guy here. This essentially loads the scene from the reality kit content bundle here. Simple as that. It says the call can throw and it's not marked with try. So we're going to wrap this inside a do catch statement to load this and catch any errors if there are any errors. So do entity.load and prefix this with try. And then if there are any errors loading it, we're going to cache that error and just do a fatal error for now. Once again, fatal errors are not a good idea in productions. You obviously want to handle the errors more gracefully, but in this case, for prototyping purposes, I won't deal with error handling here, or else we could just stay here for ages. So let's just say error loading Reality Composer Pro scene. Awesome, great. So now that error should be gone. And now what we can do is once we've tried loading this, if such an entity exists, we'll assign it to say a variable called fireworks entity, and then we could simply return that. So return fireworks entity. Awesome. So now before that, I'm just going to do one more thing. I'm also going to give this fireworks entity a name so that we can retrieve it from reality view whenever we need to update it. So I'm going to give this a name, and let's say the name is fireworks. Great. So this is the load fireworks function done. This simply loads the fireworks entity from the Reality Composer Pro scene and returns it to us as an entity. Great. So now if we go back to the reality view here, at the moment, we're trying to add a sphere which does not exist. So we're going to get rid of that. And instead, just before, we're going to pass in a fireworks entity. So fireworks entity equals load fireworks. And this is the function that we just created to load it from this Reality Composer Pro scene. Great. And now we're going to pass that entity in here to the scene. So now when the reality view is first constructed, it would load the fireworks from the Reality Composer Pro scene and add it to the scene like this. And now what we want to do is in the update closure, we're trying to retrieve the sphere, right? And then we update the position of the sphere to match the spawn position. And then we show it or hide it based on whether the gesture's hands open or hands closed. So first here for retrieving the sphere, we're going to replace this, say, with retrieving fireworks. And here the code is the same. From the reality view's content, we're looking for a specific entity named sphere. And now instead of sphere, we're looking for a specific entity named fireworks, i.e. the fireworks entity that was added to the scene. And we'll return this as just simply an entity because we don't need this to be a model entity at this point. And here I'm going to rename this to, say, fireworks. And now here I'm going to rename this again to fireworks while we're unwrapping it. And now again, replace the sphere with fireworks, just renaming things. And then finally, we add the updated fireworks to the scene. Great. Again, literally the same thing we did for the spheres, but all we're doing is replacing the sphere with the fireworks entity. And now before we try to run this, we can also clean this up a bit. So here we're just unwrapping two optionals. So we can do this in one line by doing guard let fireworks equals fireworks, and then comma let spawn position equals spawn position. And if both exist, great. If not, just return. This is just a neater way of writing what we have here. So I'm just going to get rid of this after the refactor. For now, you can see the fireworks without any audio. And when you close your hands, the firework stops. And when you open your hands, the firework resumes again. And now in the next video, we'll add the spatial audio.